We are live, probably live. Wait a minute, let me confirm. A minute. We are live. We are so live. We are so live. Dear God, চাঁদের মোড় ম্যান যাই না একজনও না এমনি করবো ভাই স্ট্যাটাসে পুট করে দিচ্ছি রে একটু চেক করে ল্যাটেন্সিটা কনফার্ম করে দে আমাকে স্ট্যাটাসে দিচ্ছি আমি will start in 15 seconds probably. Let's see. Okay. How's the latency? Good? ঠিক আছে? Cool. Hmm? Okay. Let's wait 5 minutes for engagement. Damn. তুমি কি একটু হালকা কর একটু হালকা কর স্টুডিও সবাই শুনতে পারবে এই সৌমিক একটু হালকা কর ভাই Okay, let's see. Damn. Okay. As promised, the stream should have started on Sunday, but I am really, in a bad state. YouTube needed to verify my account, which needed a lot of time. So today we are going to start a micro project. Every week we are going to catch a micro project and chill. We are going to do 30 to 45 minutes of live coding. For today it's going to be 15 minutes. And today's topic is breast cancer prediction. I'm going to be talking about the diagnosis and treatment overview along with the prediction process and the algorithms that we are going to be using. So it's obviously a project in progress, and our focus is on awareness about breast cancer and ML modeling. Let's start the introduction. Breast cancer is among the most diagnosed cancers globally. Early detection and targeted treatment drastically improve survival rates. It's also the second easiest database to work with, because the easiest database is obviously with diabetes. You need to clean it a bit, but not like another benign diseases like let's say T3, T4 thyroid cancers, which need like brown fox, red fox, or the two wolf for one wood hypothesis, something like that. I do not remember the algorithm, but these are basically the nature-inspired algorithms which need to be used while modeling the meta-heuristic algorithm for complex transformer-based solutions like this. What we are going to do today is a easy ML model. We're going to be discussing more about that, but first we are gonna talk about the diagnosis. The prevalence and statistics show that 2.3 million new cases are rising of breast cancer every year worldwide. It was given by 2020 IARC. and greater than 90% in a 5-year survival rate are shown by localized cancer. Uh, the risk is in genetics, which is shown by BRCA, the age and the lifestyle. Breast cancer, as you can see here, is shown by an image which I think WHO has given us. Uh, you can see the arrow shows small black spots around here, and we see affected cells around here. We see some, you know, discoloration, some, excess bodies. We see some, these are, I guess, WBCs, but more or less these are benign. We can diagnose them by either mammogram, which is a primary screening, a secondary imaging, which is normally known as a ultrasonic or MRI. We can do a biopsy, which basically confirms the diagnosis, or in complex cases, a biomarker testing. I do not have much information about biomarker testing, so we can skip that. But for people who are interested, here's ER, PR, HER2 status. I don't know about this. I haven't happened to go by an article and thought that this was important. Now, this is the important part, the treatment modalities. Surgery we can do, it can either be lumpectomy or mastectomy, which is, you can cut a part of the, breast. You can also, I'm not going to deep dive into this topic, but yeah, radiation therapy used for surgery to kill residual cells. Pre/post, if you want to do pre/post surgery, which rapidly target dividing cells. For example, any type of cancer, chemotherapy is the best solution, near best solution actually. Hormonal therapy, by which we use tamoxifen and aromatase inhibitors for ER plus and PR plus tumors. Again, I do not know what is ER and PR. I guess they are more like benign and malignant division. Targeted therapy, which can be trastuzumab for HER2 plus. Again, don't know what HER2 plus is. Emerging therapy is constitute of immunotherapy, PARP inhibitors, and personalized medicine. For immunotherapy, however, doctors need to be very sure while treating their patients. Immunotherapy can cause problems if even a small detail about a patient's, say, diet, say, genetic history gets skipped. It can lead to a lot of autoimmune diseases if the medicine is not proper. The outcomes and challenges, so that in a 5-year survival rate, of course, if the stage is a localized one, the survival is greater than 90%. If it's regional, then it is about 85%, which is not that good, but it's quite. If it's metastatic, then it's probably that the patient does not have much time, that is about 27%. Quality of life and continuous research are the key to progress. Now we are going to deep dive into the portion that I am going to handle. Project overview of breast cancer prediction model. Now our objective is to predict if a tumor is malignant or benign using ML. The dataset we're using is actually very widely used dataset that has been used all over the world. We're going to use the breast cancer Wisconsin diagnostic database. Uh, the dataset is actually a CSV file, which I'll show you. I have it open in another tab. The structure of the file that we are gonna make is simple. Breast cancer ML model, we are gonna have a data folder. The data folder will have the data.csv, which will have all the features, 336 features, unrefined features of a benign and malignant tumor that will basically predict that if our breast cancer is there or not. Then in our notebooks, or in this case we are using Google Colab, but we'll also have our notebooks. So we are going to do an offline version of this, in which breast cancer prediction.ipynb will be using that. Now, just in case you are wondering what IPYNB is, it's basically IPYNB. I'm gonna divide it. PY stands for Python. For normal.py, you have it. You see, we have a PYNB. PY stands for Python, NB stands for notebook, I stands for the packaging type which is being applied here. Basically, it's a JSONified uh, technique we use for notebooks to store text, codes, to run them cell by cell. It is better if we use kernel-wise executions. That time IPYNB is very useful, because consider sometimes what happens is we get an accuracy of 92%. We're not going to run the 2208 lines of code, again and again. So we'll have a cell which has the 7 lines of code or 8 lines of code, but in which we change the hyperparameter. We do hyperparameter tuning. We change the hyperparameters to achieve more and more and more. So basically, we'll train the kernel more and more. We don't have to run the 2208 lines of code. That is why we use IPYNB, a notebook file. Readme.md is MD5 encrypted. Everybody knows how a good README file you know gives you interest for the project. Sorry. uh, and requirements.txt, which will actually say what kind of requirements we need if you want to locally run this project. First, I want to make a version that runs on Google Colab. Then I might work on Jupyter Notebook, so it can completely work with the app.py, which I am gonna make. So I'm just gonna give you Python app.py, and it's gonna give a user and solution. Then the third phase which I am gonna target is an end-to-end model. Now, for the end-to-end model, I'm not gonna go with breast cancer, but for the end-to-end model, I'll go with I think the diabetic prediction model, because it's been done in MLOps with a good ML pipeline, and it's also been taught by Ayush in a course for cohort 2. Shout out to Harkirat and Ayush sir also. So here's the current status of the project. The project skeleton is set up, means the requirement, what we are gonna do, what what kind of algorithms we are using, the data set. Yes, the data set is source, and the notebook is initiated. The planned approach is data preparation, which every data scientist likes a lot. Trust me, they don't like it. It takes a lot of time for unclean data sets, but in this case it will be easier. Okay, so we import the data set, we clean the data set, means we take the data which we need, we encode the data set, means we change the data set's data to the required data type, let's say. But in this case, it's we are going to skip encoding. Encoding is pre-present, so we're going to scale the data. Scaling a data is very required when you're using with big data set. Exactly why semi supervised learning was introduced in the first place. Big data sets are trained by making a model. The model trains on a small portion of the data set, and then the whole data set is trained on the prepped and pre-trained model. It requires lesser resources, it provides better results. It's better than supervised and unsupervised learning mixed together. That is why it's called semi-supervised learning. Back to the topic, we're going for exploratory data analysis, ADA, for which we need to visualize the distributions, we need to make correlation heat maps, and for this we have our very trusty matplotlib and our SNS Seaborn. So the modeling, yes, this is what everybody is waiting for. Very basic for any project. We are going to baseline it on logistic regression. What we are going to do, we have a line, have a lot of dots which are scattered here and there. We're going to take the dots and we're going to make sure that the dots are more closer to the line. So let's say I apply regression 1. The dots are much more closer and clustered around the line. They're clustered, and now we have a baseline model. Then we'll apply random forest and grid search CV. Now explaining random forest and grid search CV is difficult in here, but let me just tell you one thing. Random forest is more or less a collection of many decision trees, where the user's decisions decide what kind of product you're getting. It makes a probability. The probability helps us predict stuff. This is for a decision tree. Now, when we work with 3 or 4 datasets or datasets with multiple features, we prefer random forest. Grid search is basically to make sure that the searching and sorting of the algorithm, is more or less faster. So, yep, what we are gonna work on, that is gonna give us the visualized, data metrics, because to data scientist, to any person, the output matters a lot, the process does not. So we are gonna give a ROC AUC curve, we're gonna give you precision, and we are gonna give a confusion matrix. Now in confusion matrix, by default you're gonna get precision, accuracy, F1 score when we mention things like that. But still I thought that confusion matrix need to be mentioned separately. The tools we are going to use is Python for programming language. Very evident, because in machine learning using R is very hard. Rust or C, if you are using, you're literal god. I don't want to talk with you if you're using this kind of stacks. Or maybe I do, but not to a good scale. We are going to use pandas, numpy, matplotlib, seaborn, and sklearn. Now I'm going to explain them one by one. Pandas is basically a Python framework which helps us, it's a part of NumPy, by the way. So Pandas helps us organize data better. NumPy, it's basically it makes the data structure of itself. We have NP arrays, we have NP maps. So NumPy basically makes visualization or organizing easier, because most world works on NP, most worlds works on NP. That's very evident. I have not deep dive into that. I am thinking I must deep dive into more NumPy documentation. But right now, what suffices my purpose is that NumPy operates completely and differently. Uh, you know, from Java or C++ arrays or something, even Python's arrays, the logic is a bit different. Where Matplotlib, it's basically a data visualization tool, just like Seaborn, but Seaborn gives you, let's say, heat maps, which are like colorful and all. But Matplotlib will give you, let's say, colorful. It's also colorful, but it will give you charts and it will give you scores. It will customize. You can customize the charts as you wish. sklearn is scikit-learn, a very important and very let's say beginner friendly resource for learning machine learning. That is exactly why it is known as scikit-learn. Jupyter Notebook / Google Colab, these are the two platforms that we are going to use for notebook. We're gonna see if there's more to it or not. Okay. For dataset, we are gonna use a sklearn built-in dataset, which I was thinking at first that we should import it, but then I thought that rather than doing that, I should show you what a CSV looks like, because maximum ML people or AI ML people work on CSVs. So it's basically Excel file, nothing so different. But let's consider if the Excel file had directions. If the Excel file had directions, it would literally be CSV. That's it. That's the only difference between an XLSX and .csv file. For our next step, we're gonna finalize the pre-processing, complete the EDA, train and compare models. That is the most important part of this project. Right now we are doing sklearn. Right now we are doing search grid CV. Then we'll need to eventually give it a good model to test on, to do performance and semantic analysis. We need ResNet 50, we need BERT 50, we need good mobile. We can do a mobile CV 70. So there are good models present in the market. We'll need to test on them and consider deployment later. We are only considering deployment. Making an end-to-end is very hard. Not very hard, but why put in that much of work when the main project is done? We can do a end-to-end for a big ML project, but it's kind of a micro project. So let's work on that. Why does this matter? Is machine learning in healthcare can transform early diagnosis. This project is a step towards building interpretable, impactful tools to assist in life-saving decisions. Now I'm gonna show you what we are working on. Data1.csv. You see, here we have certain IDs. These are all IDs for captures. Captures are very common in files like this. We have 56 columns. Okay, good. We are also loading more. I think there was more than 56. I think it shouldn't be 56. I think there should be more. Yeah, there should be more. It's not showing right now. Let me just wait a bit. The internet is. Yeah. So yeah, we. Uh, I'm gonna make it evident that I really like my hostel's Wi-Fi. It's a freaking CSV file, sir. Only music that is running in the background. Can you please load fast? Please. No live. No comments. Am I visible? Am I audible? Am I visible? Yeah, I am very sure. Jackass. Oops, sorry, this was supposed to be a PG-13, but you know, a 13-year-old isn't studying about CSV or breast cancer, so this video can be PG-18, okay? I can say jackass, okay? Okay, good. We are going to look at the CSV file which has loaded. We have ID, which are captures for the cancers, which are captures for patients who are supposed to have cancer. I'm not here supposed to give spoiler. The diagnosis, which is the final verdict, either it is M for malignant or B for benign. The radius, we have the radius of the cell, we have texture, we have perimeter area, we have lots of factors which need about the cell, but we are only gonna use the most prior features that we are gonna need. You understand? Like it's called priority feature engineering. We are gonna need what gives us the best answer. Okay, we're gonna start with our collab. Yaar chill bande. I'm just chill guy, most of the times we are not even getting to see it, man. Damn, so quick, man. I'm a narcissist. I'm a freaking narcissist. So first step is we need to import the libraries. So first we add a text. Let's put it up. Wait a minute. Let's put it up. Bold and italic. We're gonna do import what? We're gonna do import libraries. Okay. No, this is not supposed to be. Okay, great. Wait a minute. Let's do this. Yeah, now it's fine. Now it's all fine. Yeah, that's cool. All cool now. Let's see. Okay, just to make sure that the 0 people who are watching this stream are listening. We're importing cell. Now import numpy as np. Now we are gonna use Gemini AI, by the way. So shout out Gemini AI. There is no problem in using AI, but still we're gonna do things like import data pandas as PD. The data pandas or Pandas SPD. I guess it was Pandas SPD. Yes, Pandas SPD. Then perfect. Looks like our AI has given us already generated part matplotlib.pyplot is equals to plt. Okay. Seaborn as SNS. Okay, good. Pandas SPD. Okay, but now the Python libraries are imported. We are gonna import the sklearns one. So from sklearn dot dear God, Gemini AI already has everything ready in it. Okay, so let us see at it. Test train split. Okay, dot model selection. We have a linear model. We have logistic regression, which we are not gonna do. We are gonna do a linear regression. Great. sklearn dot metrics. We have accuracy score, confusion matrix, and a classification report. And for pre-processing, we have a standard scaler. Should we do a standard scaler or should we do something else? Let's look at it. Uh, no. I don't think we'll need MSE or R2 for this one. I think I'm forgetting something. We also need to show the ROC AUC. ROC curve AUC. Uh, ROC AUC curve and ROC curve display. Okay. Uh, ROC curve display. Uh, uh, nope. I think we'd rather go for logistic one. You know, linear is not gonna work. I was thinking. Okay, from model selection test train split is. I don't think cross validation is needed for a small data set. What do you think? I think we should directly import grid search CV. Yep, damn. They do not around. We need a label encoder. Yep. We need a label encoder. So now our beautiful code is ready. One thing that I learned from AI is that you should never be very dependent on it. I'm sounding kind of hypocritical, but you also get things to learn from an AI. For an example, I'm gonna show you this. You see, this is what an AI generated. This is what a normal data science engineer or ML engineer would write. Now, I was cross-referencing a few codes, trying to make sure that how an AI can make it better. It gave me one more line of code. It was warnings import warnings, and then it was warnings dot filter warnings ignore, and then we had something matplotlib, something with matplotlib. Let's say we'll keep it empty for now. Oh, it was matplotlib inline. See, the AI has also given that, you know. Okay, all our libraries are generated, and now we are gonna go to funny views. Let's see how we can proceed. Now we need to load and inspect data set. Loading data set. Loading and inspecting data set. So we are loading and inspecting our data set. It's good. Certainly present. Sorry for the minor inconvenience. It's always a good place to be here. Uh, let's see. Yeah, Duty Patri is in the chat. Damn. Yo. Basic breast cancer. Damn. Uh, my chat is broken, so I could not see your chat. Sorry. Shout out to Dutyaditya Patri, very, very close friend. Uh, Virgil chair meme. अरे आदित्य पाल also here, man. CNS jai bhar mein. अरे CNS, who cares, man? See, 1, 3, 4, and 6 are short chapters, and they are heavily theoretical. I'm not gonna remember them. I'm gonna learn them at the end moment. Second chapter is, bhasad macha level of shit. So I'm gonna have to prepare, for it a bit. 4 is a clusterfuck. I'm not gonna lie, 4 is a clusterfuck. It's a 3 days. Let's see. Back to breast cancer. So we're gonna load and inspect our data set. Is it gonna work? I have never loaded a data set in Colab. So how does the data path work? It's already given diabetes. Okay, so should I be going with this? Should I be going with this? Damn, you sure? Let's give it a data.csv. Okay, cool. I never loaded a data before. How will it know where my data is? I haven't even fed. Where to give the CSV file, man? How will it know where the file is? I have it locally. Damn, by the way, why do you choose this project? All of it is written here, man. I have made good notes. I will improve the Notion files. I'm gonna do. This stream was supposed to be on Sunday. I wanted to do one mini project or micro project. I wanted to start and live code it every Sunday. Basically, we started with this, the diagnosis and all. And the thing is, these projects are so beautiful. These projects can be used as your normal projects. This is a micro project, but this can also be transferred with the proper research literature into a research paper or a research contribution. That's what makes this better. Just test it on pre-made model. Let's say BERT 50, ResNet, mobile ResNet, 70. Use it on models like this and analyze model performance. Get a AUC ROC curve. Classification accuracy data, things like that. Don't make jokes as to where the cancer is localized. My vision is not there. I'm also I was gonna do diabetes. It's breast cancer, not because it's the second easiest data set to work with. That's it. It's not anything like that. Okay. The internet is freaked again. Okay, so we have a df.head. We have a pd. But where is the file, man? How will it is? How will it know where the file is? Df. How will it know where the file is, man? Okay, let's do a thing. Print data safe. Dear. Safe. Cool. I hope it works. We are not getting anything proper with this. And we need to drop some columns. df dot drop. Let's check which columns we are dropping. Uh, Damn, where's my CSV1 file? Don't even think about checking my history, you nerds. Bloods. Okay, so we have everything we require. Good. Okay. Looks like we have a lot of null values or zero values. Where will this end? Damn, that's a big data set, 570. Although for normal project it is small, always make sure we have the chat. Uh, if we have any unnamed columns, uh, 32 comma ID. Okay, wait, this was comma ID. Okay, so were these boots in braces? Yeah, these were in braces. Unlike this, it was not unnamed 32, it was unnamed colon 32. Okay. And we have which columns to drop and which not to drop. One name column, just in case, because we don't have any unnamed columns, but if we just do since we have got errors, you see we imported errors and we added a filter warning which is ignored, so errors equal to ignore, and inline, which we took from this matplotlib, equals to true. Okay, cool. Was it inline or no? Nice. I think it's cool, Let's run it. I don't think it will work. Yes. I need to see if I can debug this. How to add a local in Google. I have actually always imported inbuilt sklearn datasets and Kaggle links, so doing things like this is very hard. Okay, we go files icon on the left sidebar. Wait. Upload to session storage. I think that's not files. Yes. Yeah, that is it. Yep. Definitely not pictures which you wanted to see. It's cool thumbnail. Ensure that the files are saved elsewhere. The runtime files will be deleted when this runtime. Oh, yeah. It's cool thumbnail. It's cool thumbnail. Cool. Wait a minute. Let's see this live. Is it better be live? Okay. Now our data.csv is uploaded. How to access it? Select the CSV file from your local computer, then say open. Okay. Slash content slash. Could it run now? Wait a minute. Can only concatenate str not topics. Sit. Oh. Hmm. Ah. Okay. Okay. We now have 5 rows, 32 columns. Okay. Looks cool. At least we have a cleaned or somewhat cleaned version of the data set. Next we are gonna do the EDA. I probably hate life after this. Exploratory. What? Exploratory. Why? Calm. Baby, calm down. Oh. Exploratory. Analysis, which is EDA. What? Wait a minute. Oh. Great. No. Link. No link. Okay, great. EDA now. The file is added. We have somewhat clean version. Print missing values per column. Butterfingers. Are we there yet? Yes, we are successfully connected and running. The latency is very less. Let's wait for Gemini to do his magic. Okay. Do we need this? Df dot is null sum. Yes, we need it. Duplicates. Uh, Wait, we don't have any duplicates. Okay, we have columns and we have this, that. Okay, but we need duplicates as well. Hmm. Okay, let's see what we need and what we don't. Hmm. Now we're gonna need um, slash. What? What? Nah, bro. You should chill, bro. Okay, let's run it a bit and then see what we're getting. We're getting a lot of data, yes, but I don't need. We need types of columns. It's an excess. We don't need unique values. I think we don't need unique values. Let's at least get the heat map today. Huh. Got some. Hmm. Missing values per column. Okay, it's gonna go for infinite time. Okay, I'm not. Hmm. Let's start plotting. Nah, not here, not here. I think we need a new one will be much better. Slash dot plot. Plot. Yeah. X is equals to diagnosis. Completely correct. We define the diagnosis up here. Where is it? Wait, we didn't define it. Oh, it's already predefined. Okay, cool. Thought it was a function, sorry. So the X feature is diagnosis. The data is a data frame. Data title, distribution of diagnosis. Build is so cool. Let's run it. Yeah. We're getting a distribution now. Let's make a figure. 12x10. Alright. Damn man, damn. Okay. Sounds dot heat map. Correlation heat map. Okay, cool. What happened now? Could not convert string. Damn, no. Yes. What is this, man? Yeah, it's not working, man. Let's see. Sit. Yeah, thanks. Fix that shit, man. How to fix that shit? We're not going without fixing this problem. How to fix this shit? Huh. This problem. Before doing ChatGPT, we need to understand what the problem lies. Okay. Action or correlation heat map. Snippet is creating. Okay. By which we are setting the width to 10 inches and height to 10. Okay. 12, 10 rule. TL dot core. Okay. This line core heat map. Uh, this is the correlation matrix. But numbers are not displayed. Where is the problem? What is the problem? Hmm, this looks better. Let's run it. Okay. Science, I don't think I will be needing this. Hmm. Damn. Nope. Sorry, not reading chat. Sorry, the internet is really bad. Okay. Aritra Chatterjee. Sorry, man. The infrastructure is so bad. Next Sunday we'll do better. Next Sunday we'll do better. Yeah, we're gonna get a DD Skibidi Grimace Sec Drake simulator, whatever you need. Actually, we can make a snake game with OpenCV. That's what everybody thinks about. Or Skibidi it is 420 in Ohio game with OpenCV. It will be feature based. No, damn Suvayu. Suvayu, wait. Sorry for opening your channel right here. Damn. It's been some time that I, have talked to you, Suvayu. Great to know that you're still alive. You should even stream. I also used to stream, man. Bugger luck. Now I'm just going to do it because sorry for opening your channel. You know. Shout out to Subhayu. Shout out to Aritra Chatterjee. I hope that this Chatterjee is the one that I played Call of Duty Mobile. I shouldn't have said that publicly, but it is what it is. A good past that we shared. Transformers, Call of Duty Mobile. It used to be something good. Uh, you know, Back to our project. Good. So let us see if it is working. We got distribution and could not convert string to float m. Okay, just dot by dot header map. Okay, let's cut the crap. Have I imported the necessary I have not probably imported the necessary. I don't know how to fix this set. Let's ask him again, please. This calculates the correlation between. Let's first use it and see what. It's literally the same code. The thing about Gemini that I like a lot is it always gives you a use code with caution, as if we engineers are actually going to use it without a caution. Wait a minute, I have big doubts. Let me see what was wrong with the code, because as an engineer you should always know what was wrong with the code. So let's think that the numeric underscore df was invisible. So numeric underscore df dot call. So we are not directly taking the df, we are taking not directly taking the call. Okay, df dot select data types include equal to np dot number. Okay, which calculates the correlation between numeric columns encountered a non-numeric value m and the rate of rem. This is likely because the diagnosis column, which contains. I have the best chat you can ever have for a stream, you know, PDD. Sorry guys, I could not reply to you. The infrastructure is so bad. I would like to apologize a lot. I'm gonna give you shout outs, man. Or throw Suhayu. Again, shout out. Okay, so diagnosis column which contains categorical values for classification. M malignant and benign. B is when included in the population accepts all input data to the numeric. Acha. Yes. I have never fed a string data to a correlation before. How could I have forgotten, man? I have always fed numeric data to df.correlation. Then how is it gonna work? So what we are doing is we're selecting data types, we are converting it into a np.number. So the number is accepted and we have our categories. So correlation heat map. That was kind of it for today. Let's see if we want to do a bit more. For data pre-processing, I would rather not. It would take a lot of time for using the model, making confusion matrix, ROC curve. Then we'll go for wait. Let me see first. EDA is complete. Data pre-processing is next. Next is logistic regression, which we will be applying. Then ROC curve. Then random forest with grid search CV. We'll be doing hyperparameter tuning here. So we'll be making parameter grid and all, confuser matrix, ROC curves, and then basically we'll be getting our legend. I think that's enough coding for today. I also have my CNS exam, need to attend it, guys. Bye bye, guys. But we won't stop till we have 10 orgos, saying bye at each other. Yes, 2. Three. 4. 5. Six, 7, 8, 9. Probably got the 10th one, but we are not able to see. That's 1 minute. See you tomorrow.